Hello friends, we are dealing with project A variant agglomerative approach for text document clustering under the guidance of Professor N. Sandhya, HOD of CSC Department Greek. Our project members are Meghana, Nandini, Geethanjali, Prathibha. Coming to our project, text mining is our domain. The aim of our project is to find out the efficient similarity measure based on minimal number of accurate clusters formed. Let us understand what is meant by text document clustering. It is one of the important techniques of text mining in effectively navigating, browsing and organizing large amounts of information into a small number of meaningful clusters. Cluster analysis is an unsupervised learning method that aims to group instances into different subsets or clusters such that each cluster contains similar observations with respect to some predefined criteria. Here in this proposed algorithm, the documents that are more similar are grouped into clusters initially, unlike the existing approach, in which the clusters are formed initially by assigning each object to its own cluster and then repeatedly merging pairs of clusters until a certain stopping criteria is met. Document clustering is the process of grouping documents with similar contents or topics into clusters to improve both availability and reliability of text mining applications. Example: information retrieval, text classification, document summarization. This diagram depicts the process of document clustering. Initially, few text documents are considered and keywords are identified from those documents, and term frequency matrix is constructed, which is given as input file for our project. This is the input file. We are dealing with agglomerative approach, which is a type of hierarchical clustering. So let us understand what is hierarchical clustering. It works by grouping data objects into tree of clusters. Our project is on variant agglomerative approach unlike existing algorithm. Let us see the difference between them. In the existing algorithm approach, each document forms separate clusters and these clusters are merged until a termination condition is met. Proposed algorithm. The documents that are more similar are grouped into clusters initially. From the unclustered documents, the documents that are more similar may be either merged with the initial clusters or a new cluster is formed. This process repeats until all the documents are clustered. We need to pre-process the documents and build vector space model before applying the algorithm. Pre-processing consists of steps: removal of stop words, stemming, prune the words that appear with very low frequency. Stop words. Many of the most frequently used words in English are worthless in retrieval and text mining. These words are called stop words. Why do we need to remove stop words? Stop words accounts 20 to 30% of total word counts. Improve efficiency. Stop words are not useful for searching or text mining. Stop words always have a large number of these. Stemming. The words that appear in documents often have many morphological variants in bag of words representation of documents. Morphological variants of words have similar semantics interpretations. Stemming algorithms have been developed to reduce a word to its stem or root form. The key terms of a document are represented by stems rather than by the original words. Similarity measures. Similarity documents are grouped to form a coherent clusters in document clustering. A variety of similarity measures such as cosine similarity, Jacob coefficient, Euclidean distance, Manhattan distance for document clustering. These are the various similarity measures and its formula. Algorithm. Represent the document in vector space model. Generate the similarity matrix for the documents by using similarity measures. Find the minimum value from the similarity matrix other than 0. Find the document pairs with the minimum value found in step 3 and assign the value 0 in the similarity matrix for the document pairs which have the minimum value. If there is only one pair found in step 4, make it as a cluster. Else, if there are multiple pairs found in step 4 and if they are disjoint, form them into separate clusters. Otherwise, merge them. Repeat step 3 and step 4 for unclustered documents. If one of the documents from the pairs belong to previously clustered documents, then merge the other documents to the previously clustered one, otherwise form a separate cluster as in step 5. Repeat step 6 till all the documents are clustered. Explanation of algorithm with example. Generate the similarity matrix. Consider the similarity matrix generated for the 9 documents. From the matrix, consider either the upper triangular matrix or lower triangular matrix because the distance between the pairs 1 to 1, 2, 1 is same. From the upper triangular matrix, the maximum value is 9 and the minimum value other than 0 is 1. According to the step 3 and 4 from the algorithm, the document pair with the minimum value 1 is 39, assign the value to 0 in the similarity matrix at the position 39. There is only one pair, so create a cluster with document 3 and 9. In this picture, you can see the 1 is replaced by 0. Step 6. Next, minimum value is 2. Consider the pair of documents that are unclustered. We have the pairs 3, 4, 4, 9 with the minimum value 2. The minimum value 2 is present for the cluster for the pairs 3, 4, 4, 9 and assign the similarity between those pairs to 0 in table D. But the document 3, 9 already belongs to the cluster created previously. Therefore, merge the document 4 into the cluster. So now the cluster is formed with the 3, 9. After we are done with all the iterations, the result obtained is this. Execution is carried out in this way. We have a browse button through which we take an input file. As we mentioned before, we have the 4 similarity measures. Suppose first click on cosine similarity and submit. Then we find a new window where we get the details of number of clusters formed. For cosine similarity, number of clusters actually formed 126 and number of clusters after merging 18. When we click on cluster information button, you will get a details of cluster information table. This table shows how many documents present in each cluster. If you see the first row, the number of CAGs are more. So cluster 0 is called CAG cluster. When we click on show folder button, we get a window. This window is a file tree representing cluster which are formed by 4 similarity measures. As we mentioned before, cluster 0 consists of CAG documents. This is representation in the file tree. In Jaccard question, number of clusters actually formed 128, number of clusters after merging 21. In Manhattan distance, number of clusters actually formed 14. In Euclidean distance, number of clusters actually formed 36. Conclusion. The clusters are formed for all the documents using a variant agglomerative approach implementing in 4 similarity measures. Varied results were obtained for the same representation with the different similarity measure. As a result, it can be concluded that maximum capturing using cosine similarity has better performances as it produces most similar clusters than other similarity measures. Future enhancements. The clusters formed can be made concept or context grouping of documents by using some extra criterions like synonyms or relation between the words. The formed can be made more efficient by taking only few important words rather than taking all the words. In future, we expect to find specified number of clusters so that we find accuracy of formed clusters. Thank you.